But what actually happens to the human body when the oxygen runs out? Welcome to this explainer. Today, we're looking past Hollywood's dramatic interpretations and diving straight into the hard, clinical data of asphyxiation. We're going to decode one of the most critical and time-sensitive processes in human biology, mapping out the physiological chain reactions and the undeniable physical evidence left behind.
Here's exactly how we're going to break this down today. First, defining the breathless state. Second, categorizing oxygen deprivation. Third, the vicious cycle. Fourth, the 3 stages of failure. And finally, forensic clues and signs. Let's just jump right in.
All right, part 1, defining the breathless state. To truly understand the end result of oxygen deprivation, we've got to define the starting point.
Now, get this. It's actually a pretty surprising medical fact that the word asphyxia translates literally to pulselessness in ancient Greek. But modern forensics fundamentally defines it as an issue of respiration, not the heart. Technically speaking, it's a state characterized by an acute lack of oxygen available for cellular metabolism, compounded by the body's sudden inability to eliminate excess carbon dioxide. The heart keeps desperately pumping, doing its job, but without that crucial oxygen exchange, that ancient concept of pulselessness, it eventually becomes the inevitable consequence.
Moving right along to Section 2, categorizing oxygen deprivation, because forensic experts don't just look at a generic lack of air.
We can organize this using the ASHA mnemonic, ASHA. It's a great way to break down exactly how anoxia, or oxygen deprivation, happens inside the body. First up, anoxic. This is when the lungs literally cannot oxygenate the blood, maybe due to high altitude or a mechanical obstruction. Second is stagnant. This is a circulatory issue. The blood physically slows down due to heart failure or shock, so oxygen delivery just stalls. Third, histotoxic. The oxygen arrives, but the cells themselves are poisoned and can't use it. Cyanide poisoning is a prime example here. And finally, anemic. This is where the blood loses its capacity to carry oxygen entirely, which we see in carbon monoxide poisoning or severe hemorrhage.
So ASHA covers the internal cellular failure, but what about the external triggers? These are the real-world events that kick off the breathless state. We've got mechanical causes, which actively block the airway, think smothering or strangulation. Traumatic causes involve severe chest compression, like being caught in a stampede where your muscles literally cannot expand to pull in air. Environmental causes put the person in a space with no oxygen to breathe in the first place. Toxic causes involve poisons like carbon monoxide. And lastly, pathological causes are disease-driven, like severe pneumonia or a sudden acute swelling of the airway.
Okay, let's turn to part 3, the vicious cycle. This is where we look at the terrifying biological mechanics at play.
The absolute crucial takeaway here is this grim physiological loop. Asphyxia begets asphyxia. Once that delicate system of oxygen delivery is interrupted, it creates a massive snowball effect. The crazy thing is, the body's natural, desperate attempts to save itself are exactly what accelerate the systemic shutdown. Now, to really grasp this runaway train of pathophysiology, our goal was to give you a detailed explanatory video using flowcharts auto-generated to map out this exact sequence. So, looking at the steps. Step 1. Oxygen tension immediately decreases in the blood, which forces your capillaries to dilate. Step 2. Because those tiny blood vessels widen, you get stasis, a massive engorgement of blood just pooling inside the organs. Step 3. With all that blood trapped in the organs, there's a severely diminished return of blood back to the heart. And finally, Step 4. A starved heart means reduced pulmonary blood flow to the lungs, which further prevents the lungs from oxygenating whatever blood is actually left. It's a broken loop that speeds up failure in a matter of moments. Which brings us to Section 4, the 3 stages of failure, the actual biological countdown. When this countdown begins, the speed of the shutdown is honestly terrifying. We're talking about a total window of just 4 to 6 minutes from a normal resting state to irreversible damage. In the very first minute, we hit the stage of dyspnea. This is pure panic, intense breathlessness, a racing heart, which doctors call tachycardia, and ringing in the ears. Moving into minutes 1 and 2, the body enters the stage of convulsion. Carbon dioxide is building up so rapidly in the blood that it causes labored, spasmodic breathing, spiking blood pressure, and completely involuntary convulsions. And then by minutes 2 and 3, we enter the stage of exhaustion.
Let's just pause heavily on this final, fatal stage of exhaustion because it really highlights the extreme fragility of our biology. In just a few short minutes, the person reaches complete insensibility. Literally all bodily reflexes are lost. The pupils become widely dilated, and the severe lack of oxygen results in devastating anoxic brain damage, which ultimately paralyzes the respiratory centers in the brainstem. At this point, that vicious cycle we just mapped out, it's run its full course.
Finally, Section 5, Forensic Clues and Signs. When that continuous loop of oxygen breaks, what physical evidence is left behind?
Forensic pathologists draw a very firm line between specific telltale markers and non-specific postmortem findings. Specific signs are your absolute red flags: cyanosis, Tardieu spots, organ congestion, and excess fluid in the lungs, known as pulmonary edema. On the flip side, we have non-specific signs. Now, historically, things like the fluidity of the blood or a dilated right heart chamber were seen as absolute proof of asphyxia. But modern science has shown us these can actually happen in all sorts of different types of death, so they're totally non-specific. If you want the real story, you have to look for these specific signs.
Let's zoom in on one of the most famous forensic indicators you might have actually heard of, Tardieu spots, or petechial hemorrhages. Think back to that vicious cycle of failure we talked about. When oxygen drops, capillaries dilate and blood pools. Well, this causes an acute, massive spike in venous pressure. The pressure gets so incredibly high that the super thin walls of the body's tiny venules literally just burst. And that leaves behind these chilling forensic signs, these tiny pinpoint collections of blood, most often found in the eyes, on the face, or on the internal organs.
And then, of course, we have cyanosis. This is that characteristic bluish discoloration of the skin and mucous membranes. It's usually most visible in areas totally packed with capillaries. Think the lips, the nose, the nail beds. The dark, deoxygenated blood pooling in these areas is what gives the skin this distinct blue hue. It is the literal physical manifestation of the oxygen starvation and that exact pulselessness we defined at the very beginning of this explainer.
So we've moved from a sudden lack of air through a vicious physiological loop all the way down to the bursting of microscopic blood vessels. And it all brings us back to why we study this stuff in the first place. How does understanding these clinical forensic markers allow science to speak for those who no longer can? These tiny clues, a blue hue on a nail bed, a pinpoint hemorrhage in the eye, they are often the very last witnesses left to what happened in those final, frantic minutes. Understanding this biological countdown, it's not just about pathology, it's absolutely crucial for the pursuit of truth and justice. Thanks so much for joining me on this explainer, and I hope this forensic breakdown leaves you with a profound appreciation for just how fragile and intricate the mechanics of the human body really are.